Behind every massive wireless deployment, there's actually a surprisingly fragile, like highly expensive strand of microscopic glass. So welcome to today's deep dive. We are looking at a spec sheet from HDTVSupply, specifically for the DVIGear DVI-2345-FOD 8X LC optical plenum cable.
Yeah, and when you're dealing with enterprise infrastructure, I mean, the physical tolerances are just brutal. We're really dissecting the underlying physics and chemistry today.
Right, the stuff that makes this cable a non-negotiable requirement for high bandwidth environments. Okay, let's unpack this, because getting a 45-meter run of this specific fiber into, say, a commercial data center or a broadcast facility, that's what actually keeps mission-critical AV systems from collapsing under their own data weight.
Exactly. They generate so much data.
Yeah, so let's start with the 8XLC connector design. I mean, we're obviously looking at multi-channel connectivity here, kind of like an 8-lane digital superhighway to prevent bottlenecks.
Right, which is crucial.
Right.
And terminating 8 precise LC connections at the factory is, well, it's notoriously difficult to keep perfectly aligned.
Oh, I can imagine.
But what's fascinating here is the physics required to maintain that signal integrity across the specific fiber they use. The spec sheet lists it as 50/125U MMF.
Which is multimode fiber, right?
Exactly, multimode fiber.
So let's dig into the mechanics of that 50/125 ratio. The 50-micron core, that's the central data pathway. I mean, that's literally thinner than a human hair.
It is. And the 125 microns refers to the cladding surrounding it. So think of multimode fiber like skipping stones down a microscopic pipe.
Oh, okay. Skipping stones.
Yeah, you're bouncing multiple light modes off the internal walls at different angles simultaneously. The 125 micron cladding basically acts as a mirror.
Because it has a lower refractive index than the core?
You got it. It continuously bends the light pulses back to the center using total internal reflection.
Wow. And that refractive boundary is really the only thing preventing data from just leaking out into the jacket over that entire 45-meter length, which is 147.6 feet.
Right. Without that specific optical mirror, high-speed data transmission just degrades into noise almost instantly. It's incredibly precise manufacturing.
Engineering glass to a 50-micron tolerance certainly explains part of the manufacturing difficulty. But, I mean, let's look at the physical deployment. The MSRP on this 45-meter run is $524.
Yeah, it's definitely not cheap.
No. Even factoring in the site's 10% off discount, free USA shipping, and the 3-year DVIGear warranty, that is a serious investment for one cable.
It really is a lot.
Like, I see the 10-meter is $249, and the 75-meter jumps up to $760. Wait, $524 for 45 meters seems kind of absurd when standard patch fiber is just a fraction of that cost. Is the Plenum-rated CMP jacket listed here basically just a massively marked up fire insurance policy?
Well, no, it's actually a strict legal mandate under the National Electrical Code. CMP stands for Communications Multipurpose Cable, Plenum.
Okay, so it's required by law.
Exactly. Standard PDC jackets are cheap, sure, but if they catch fire, they act like a wick. They release this highly toxic, thick black smoke.
Oh, right. And because the plenum, the dropped ceiling or the raised floor, that's literally the air handling space that circulates breathable AC to the entire building.
Yeah, so toxic smoke in that space is a catastrophic life safety failure. You're paying for specialized fire-retardant chemistry here.
Like what? What's it actually made of?
Plenum jackets are typically made of Teflon or FEP plastics that actually self-extinguish and emit minimal smoke.
Okay, that makes sense. So combine that environmental engineering with the commercial-grade durability of those factory-terminated 8XLC connectors, and you aren't just buying data speed.
No, not at all. You're buying strict code compliance and flawless long-term deployment.
So what does this all mean for you? Whether you are an AV professional architecting a telecommunications hub, or maybe just a systems designer analyzing building specs, unpacking a document like this reveals the uncompromising physical and chemical standards required to actually deploy our digital network safely.
Yeah, you really can't just run any cheap glass through a ceiling and call it enterprise grade. It doesn't work that way.
Definitely not. So next time you walk through a massive enterprise building, just look up at the ceiling and ask yourself how much of your seemingly wireless life is actually completely dependent on highly specialized invisible optical glass highways just like this one.